I'm Mark Cavanaugh for Cavi Coaches, and today I'm going to coach you up on the scientific method, and we're going to conduct a lab investigation. Alright, so the setup I have here is I've got a ramp, a whiteboard ramp, and I've got a battery-powered car. So what we're going to do is we're going to make some observations about this car. Alright, need to see it again? I guess you just could have rewound it, but that wouldn't have been as fun to watch it again, right? So let's go ahead and pause the video at this point and go ahead and make some observations, and I'll put some observations that my students have made in the past on the screen. So some of the observations that you made in this lab were facts. So such as maybe you said the car has 4 wheels or the car is gray. Those are facts that are not quantifiable, that are variables that we can change. Of course, we don't want to change the fact that this has 4 wheels because we want to maintain 4 wheels. So if you were conducting this on your own, you'd want to have somebody at the end, or you be able to get to the end of the ramp to catch it. So car's plastic hitting tile floor, not a good thing. So what we're going to do is we're going to go through a list of our quantifiable variables. So what we're looking at, you may have said, well, the ramp is laying flat. Well, yes, it is. The ramp is laying flat. It does not have any kind of incline to it. So we could make it an incline. So that's one variable that we could change. So something else, you may have said, oh, the speed, we could measure the speed. Well, the observation of measuring the speed, we could measure the speed, but not necessarily with just a stopwatch and a meter stick. So with a stopwatch and a meter stick, we could maybe figure out what the speed is. So we would have to take measurements of displacement and time. Now you may say distance, displacement, what's the difference? Well, distance and displacement have 2 very different meanings. Distance is just how far you have traveled from where you started moving, whereas displacement only matters how far you are from where you started. So I could say the car moved here and then back, and it has a distance of 2 meters, but it only has a displacement of 0 because it started and ended in the same place. So we're going to use displacement versus time. So we're going to have measured displacement, and of course we're just going to let the car move in this direction, so displacement and distance in this case would be the same thing. And then we could also measure a stopwatch reading that you're going to use and provide at home when we collect our data. So the measurements that we can change, we have first off the incline of the ramp, which is something that we're not going to change. So a variable that you can change but you're not going to change is called a control. So we're going to leave the ramp as a controlled variable, meaning we're not changing it, it's staying the same. So the other variables that we're going to test are position or displacement and time. So go ahead and collect your data. When you are done, you're going to plot a graph of time on the horizontal axis and position or displacement on the vertical axis. And because it is a horizontal displacement, we're going to use the letter X for horizontal displacement. And my markings on the ramp are, the colored are 20 centimeters apart. The blue, the green, the orange, the purple are 20 centimeters. And the black dashed lines represent every 10 centimeters, starting from a position of whatever you define the first red line to be. So go ahead and collect your data. In the next part of the video, go ahead and plot some points on a graph, and we'll talk about finding the mathematical model that represents the motion of this car after you're done collecting.
just timed the car to the end of the ramp all 10 times, how many data points do you have? You actually only have one data point that you had 10 different trials for. So you could average all of those points and you only get one data point. So what you need to do is you need to change the positioning of where the car is and time it to different positions. You have 1 point, you just need to do 9 more points. So now that we've collected data correctly, we've got 10 data points. So we're going to go ahead and sketch, like we said, position on the vertical axis and time on the horizontal axis. Now, when you look at your data points, you should see that I should get a nice, perfectly straight line that fits right through those data points. So I go ahead and sketch a line. In physics, we like to deal with lines because lines are much easier to deal with because we only have to describe what the slope and the vertical intercept mean, which is what we're going to do here in just a minute. So in either Algebra 1 or Math 1, whichever state that you live in or whatever your school offers, we learned that the basic equation slope-intercept form of a line is y equals mx plus b. Now, this is the basic equation that we're going to use to write our mathematical model. The mathematical model is basically the equation of the line of best fit, but described with variables using physics, not just using y and x. In physics, you may use y and x together one time, but for the most part, you're going to use the variable that is each variable represents. So what we're going to do, we're going to cross out y, and we're going to replace it with what we graphed on the y-axis, which is position, which we represented horizontal position with the letter x. So now we're going to look at the slope. We cross out the slope. I like to put the slope in parentheses. The reason I put it in parentheses is it differentiates because we're going to have some letters or numbers and letters in there. So I'm going to say, let's say our slope was 25. I just made that number up. You probably got a different slope than I did, but 25 is the number. Now we have to look, what are the units? Every time we write a number, we need units on it in physics. So I'm going to look here, rise is centimeters, and the run is seconds. So slope is rise over run. So I'm going to put my units as rise over run, centimeters over seconds. Now, what do we have graphed on the x-axis? Let's go ahead and cross out the x, and we replace that with time, t. Now we look at our vertical intercept. The vertical intercept is here, it's 0. Now, so let's go ahead and talk about what this slope means. 25 centimeters per second, or a better way to read that is 25 centimeters for every second. So 25 centimeters for every second, 25 centimeters for every second, 25 centimeters for every second, 25 centimeters, it moves in 1 second. So our slope tells us that the car is going to move 25 centimeters in 1 second. We don't necessarily want to talk about the slope meaning rise over run. We need to talk about its physical meaning for each lab. So in this case, the physical meaning is velocity. So our slope represents the velocity, or in this case, the average velocity. All right, so now we need to take a look at what the vertical intercept represents. So maybe you didn't have a vertical intercept that was 0. Maybe you had a line that was shifted up and we had a non-zero vertical intercept. Well, what does that mean? So maybe if this happened to you, maybe you started your stopwatch the moment the back tires crossed that first red line, and you stopped the stopwatch when the front of the car crossed a line. Well, if that was the case, then what would your vertical intercept represent? Well, wherever the front of the car was at time 0. So at time 0, the front of the car would not have been at 0. So the vertical intercept represents the starting position of our car. Now we're going to go ahead and write the general equation. So we have our specific equation of x is equal to 25 centimeters per second times t for the car, whatever your slope was. So the x represents the final position. The slope represents the average velocity. So we're going to write a v and we're going to put a bar over the top of it. And then we're going to write t plus x naught means the positioning at time. X with a 0 represents the starting position, or x naught is how it's pronounced. Or you might see it with a lowercase I for initial position. So here we have our general equation that we derived from collecting 10 data points for 10 different positions and 10 different times. Have a great day, and even better tomorrow. If you found this video helpful, don't forget to subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.